Hide that. And away we go. Okay. So let's look at this little situation here. Okay. All right. I have a circle and I have 1 point on it. So there's one region. Once I put 2 points on the circle and connect those 2 points, I've made 2 regions. If I put 3 points on the circle and connect the 3 points, I've made 1, 2, 3, 4 regions. If I put a 4th point on the circle and connect all the points as many ways as I can, I've made 1, 2, 3, 4, 5, 6, 7, 8 regions. So 1 point, 1 region. 2 points, 2 regions. 3 points, 4 regions. 4 points, 8 regions. So if I would make a circle and I would put 5 points on it, 1, 2, 3, 4, 5, and connect those points as many times as I can, how many regions would I make up? Thomas. 16 regions. Thomas, explain the reasoning behind your 16 regions, which is the correct answer. Because they keep doubling every time. Thomas used what was called inductive reasoning, vocab word. Okay, write down from there until there, well, basically there until there. Okay, and inductive reasoning is a type of reasoning that reaches conclusions based on a pattern of specific examples or past events. Thomas took the pattern that he saw and made a conjecture, which we'll talk about in a second, a guess on what the answer would be. Okay? So, inductive reasoning is a type of reasoning we use every day. We see something in life and we make a guess on what will happen next. Okay, so inductive reasoning. You look at a pattern and you see what's next. So let's look at this example. 88, 82, 76, 70, 64. What's the next number in that pattern, Christian? 50 something. 58. What's the next number after that, Aiden? 52. What's the pattern going on there? Maddie? Okay, everybody? Subtracting 6. Just subtract 6 every time, okay? Subtract 6, subtract 6, subtract 6. Okay, look at this pattern. Okay. 1, 2, 3, 4. Oh, we got a vocab word. Here we go. Conjecture. I said something about a conjecture just a little bit ago. A conjecture is an unproven statement or rule based on inductive reasoning. Okay? So that's what we've been doing, is making conjectures, guessing what will be the next answer. Okay? So conjecture is an unproven statement or rule based on inductive reasoning. All right. So what conjecture could be made about the number of dots in the nth? In the nth term. Okay? All right, so term 1 has 2 dots, term 2 has 3, term 3 has 12, 4 has 20. Okay, how about, well, what would the 5th term have? Thomas? 60? I don't think 60. Not 25, Jack? Not 36, Mia? 30. There we go. It's 30. Okay, we got to figure out the pattern going on here. Okay. This is 1 row by 2 columns. 1 by 2 equals 2. This is 2 rows by 3 columns. 2 by 3 is 6. This is 3 rows by 4 columns. 3 by 4 is 12. 4 rows by 5 columns. 4 by 5 is 20. So the next one would be 5 by 6. Okay. What about the nth number? We don't know what the nth number is, but some number way out there. Okay? How do I figure out the nth term? Now look. Look at this and this. This and this. This and this. How many rows will the nth figure have? Not 5. How many rows will the nth figure have? If the first one has 1, and the second one has 2, and the third one has 3, and the fourth one has 4, how many rows will the nth one have? N rows. Now, what did I do with the number of rows? I multiplied it by the number of columns. How many columns compared to the number of rows do we have? 1 more. So I'm going to take n times 1 more. N times n plus 1. That's my pattern. Okay? The number of rows times the number of columns, and the number of columns is always 1 more than the number of rows. So the number of dots will be n times n plus 1. That's my conjecture. Okay? Let's look at this one quick. If these are bowling pins, how many pins do I have here? 10. If I added another row, how many would I have? 15, because I'd add 5 more onto that. Okay. All right, this one's an easy one. Table shows the temperature of water as it's heated at a constant power. What pattern do you see? And predict what the temperature of the water will be after 16 minutes. Okay, so we're not just looking at the 5th minute or the 6th minute. We're going all the way out to the 16th minute. Okay, what is my pattern? Am I multiplying by something each time, or am I adding something each time? Okay, adding how much? I'm adding 4.7, so I add 4.7 here. I add 4.7 here, and so on. Okay? So to get out to 16, what am I going to have to do? Take 16 times 4.7, because I'm having 16, 4.7 temperature degree increases. So if I multiply, 7 times 6 is 2, carry the 4. 7 times 1 is 7, plus 4 is 11. 4 times 6 is 4, carry the 2. 4 times 1 is 4, plus 2 is 6. We add them together is 2, 5, 7. Should be 75.2 degrees, right? No, it's not 75.2 degrees. Where did I go wrong? The answer is not 75.2 degrees. Mia? 0 started at 20.1. So we have to add on that starting temperature, okay, to get 95.3 degrees. That is the temperature it will be after 16 minutes. So be careful there, okay? You can do the math all right, but if you forget a little piece of information, you're going to get a wrong answer. So you got to make sure you get the whole information in there. Now, so far we've done a lot with conjectures. Now, some conjectures aren't always right. Some conjectures, you come up with a counterexample. And a counterexample is an example that shows a statement or a conjecture is false. A counterexample is an example that shows a statement or a conjecture is false. So a student made a conjecture about diagonals of a polygon. All right, so this polygon has 4 sides and it has 2 diagonals. So they made the conjecture, well, there will always be 2 less diagonals than there are number of sides of a polygon. Okay, that sounds reasonable, right? So if you have 5 sides, it should have 3 diagonals, right? But if we actually look at a 5-sided figure here, how many diagonals does it have? 5. So that disproves their conjecture. That's a counterexample that disproves their conjecture. That shows their conjecture is false and they do not know what they're talking about when it comes to that pattern. Okay, so that's a counterexample. So let's look at this one. Here's a conjecture that a student made. A polygon with 4 congruent sides is called the square. That sounds right, right? Okay. But there's a problem there. Is there a figure that would be a counterexample to that? What figure would be a counterexample to that? What do you think, Tate? Not all parallelograms have 4 congruent sides, so we can't just say a parallelogram. I just wonder if there's something that has 4 congruent sides up there. A rhombus has 4 congruent sides. And is a rhombus a square? No. So my counterexample would be a rhombus. A polygon with 4 congruent sides just isn't a square. It is a square and a rhombus. So their conjecture that it's just a square is wrong. Okay, so we provided what is called a counterexample here. All right, so in summary, inductive reasoning, you look at patterns. That's what we started with. We started looking at patterns to figure out a conjecture. Okay, we made a generalization and then made a conjecture. So here's a pattern that they came up with. 0 squared plus 0 plus 11 is 11. 1 squared plus 1 plus 11 is 13. 2 squared plus 2 plus 11 is 17. 3 squared plus 3 plus 11 is 23, and so on. You got 11 here, 13, 17, 23, 31. They're all prime numbers. So if we go 5 squared plus 5 plus 11 is 5 squared is 25, 30, 41. 41 is a prime number. And if we keep going on that, we should get all, they say, as the pattern continues, there's some, this sum, this sum, this sum, they're all prime numbers. So they make a conjecture. If n is a whole number, then n squared plus n plus 11 is a prime number. But wait, not so fast. If you take 11 squared plus 11 plus 11, you get 143. 143 looks like a prime number, but it's not. What 2 numbers multiply to make 143? 12 times 12 is 144. 11 by 13. So that makes 143 a composite number. Because to be a prime number, you have to multiply by just 1 in itself, and it doesn't have any other factors. We have other factors there. Okay? So that is a counterexample, a conjecture, a pattern. So that's what you'll be doing on today's assignment, looking at patterns. Most of the today will be patterns, but you'll come up with some counter examples and that as well. The assignment isn't super difficult. Now, you have an hour, well, just a little less than an hour to work on this. Now, some of you didn't finish section 1.3 assignment. So go back and finish. Once you get 1.4 done, go back and finish up 1.3. So let's get all of 1.4 done today and all of 1.3 done today, please, because several of you don't have 1.3 done. Okay, so get things done. Jack, you want another try at that?
I know what I did wrong on it too.
Uh-huh.
Green said that, and I didn't put that as negative.
Yeah. So do your assignment, and then I'll give you one more chance on that quiz. Okay? I don't know where she went. Okay.
Fix it later.
So let's get it done. Did you do corrections? Thank you. Oh, didn't I put it out there yet? No, I didn't put it out there yet. I will put it out there now. All right. So let's realize classes, my library. Boom. Assign. G. 2. Start today. 2. All right. So today, work on section 1.4 first. Then if you didn't get done with 1.3, go back and do 1.3. If you're done with both of them, get a Quizlet going and start studying your vocab words on Quizlet because you have the vocab quiz on Tuesday. So you have plenty of work to do over the next 47 minutes.
Oh, that's it. What time is it? Just do 6:25. I understand. I'm off to go.
Oh, you
What is it? Hot cigar. I have to go. Seven. Yeah, 6:60. What if you didn't make your mind on yourself? Okay. She said.